Okay, today we are going to be going over 2.2a. We're moving away from addition and subtraction into multiplication and division, but before we do that, this is your final quick pull on adding and subtracting integers. We've got multiple things going on here, so it is important that you follow the order of operations in order to do this successfully. Pause the recording to give yourself enough time to get this done. And now we are returning, and you should have gotten the answer of 16. 16 is correct. We can see right out of the gate we have 5 subtract a negative 2. We've talked about this a lot. Taking away rocks works the same as adding balloons. So I can rewrite this instead of 5 minus a negative 2 if it helps, which it does in my opinion. I can think of this as 5 plus a positive 2. Then I can continue on, plus 16, plus a negative 7. Now that I have rewritten that, I can see 5 plus 2 is 7. Plus an extra negative 7. So I'm only doing one thing at a time, going in order from left to right. Now going in order from left to right, I have 7 plus 16. Well, 7 plus 16 is 23. Bring down that plus a negative 7, and 23 plus a negative 7, all that we have left to do is equal to 16. You can also see, because we can rearrange these, you could think about this as 7 positive tiles, 7 negative tiles, and when you have 7 positive and 7 negative, those are all going to zero out, leaving us with just 16. So you could have thought about it that way as well. So the correct answer here, 5 minus a negative 2 plus 16 plus a negative 7 is equal to 16. And now we are going to be looking at integer multiplication. So we are going to be doing 2.2a, multiplying integers using a number line. Before we do that, there's a few things that we need to discuss. Number one, review this information. We saw that we had a really important need that we needed to change subtracting a negative to adding a positive in that last warm-up example. So remember, taking away rocks makes the basket go up. We can also make the basket go up by adding balloons. So since they have the exact same result, taking away a negative has the same result as adding a positive, we can change subtracting a negative to adding a positive. We can make that change ourselves. When we do that, it makes the problem more intuitive. It makes it easier for us to just mentally be able to handle without having to do some mental gymnastics. Similarly, and this is one that maybe makes sense to change and maybe doesn't. Taking away balloons makes the basket go down, just like adding rocks makes the basket go down. So depending on the problem, it might make more sense to rewrite subtraction to be adding a negative. You're going to see this a lot as we move on to expressions in a future unit. But this would be the most applicable if this problem, instead of 7 minus 2, if it were negative 7 minus 2. Because changing this now to negative 7 plus a negative 2, we can handle it as rocks plus more rocks is going to equal rocks. Now, that's not what the problem said, but there are times where it's going to make the most sense to do that, and some times where maybe it's better to just keep it subtraction. But you have that option. You can change it to be more intuitive, to be more helpful if it works better for you. The last thing that we need to review before we dive into 2.2a, all eyes should be on the screen right now. Please review your vocabulary word opposites. It is up here on the board. Review this definition. 2 integers are opposites if they are the same distance from 0, but on opposite sides, meaning relative to 0, of the number line. So 8 and negative 8 are opposites. Not only are they opposites, we can say this word right here, negative 8, we could say it as opposite of 8. That's really important. You can see the visual. 10 is on the opposite side of the number line as negative 10. They're on different sides of 0. Yes, Grant? Negative 6 and 6 are part of the examples. Non-example starts here. Thank you for clarifying. This is going to be incredibly important today. So please remember this concept of opposite. I'm going to pause the recording as students repeat this back to each other. All right, and now that students have had a chance to review that with each other, we're going to review multiplication. Not the new multiplication where we're using integers, but just regular old-fashioned multiplication that you did in elementary school with positive integers. And what we did in elementary school, we realized that we can model multiplication in multiple ways, like arrays, skip counting, number lines, blocks, just drawing pictures, etc. What we learned is that when we have a problem like 3 times 5, and yes, we're using the old-fashioned X symbol for multiplication for this lesson, this 3 times 5, what it really tells us is that the first factor tells us how many groups. So we would say this as 3 groups of, meaning I would have 3 different groups, and inside each of those groups there would be, the second factor tells us how many are in each of those groups. So 3 groups of 5. And that's where we get to this key sort of idea that of means multiplication, because we see 3 groups of 5. And the product tells us how many of those objects we end up with in the end, after I count up everything in all of those groups. So here are different ways that we may have represented this in elementary school. This is an array, or also sometimes known as an area model, where we can see 3 by 5. You can actually count those groupings, 1 group, 2 groups, and 3 groups, and each one of those groups has 5 of those little counters in it. You can do the skip counting method, where you can show 1 group of 5, a second group of 5, and a third group of 5. We count those groups by jumping. So 1 jump that's 5, a second jump that's 5, and a third jump that's 5. And we can actually draw physical groups, and this is one of my favorite ways of doing it. We can actually draw 3 circles, and each one of those circles, we're going to put 5 of those little counters in there. So that's how we may have represented that in elementary school. What I want us to do, though, because we're not in elementary school anymore, but I want to take some of the same thinking, and I want us to model each of these problems. Let's just go one at a time. Here's the first one. It says 3 times a negative 5. How should we be thinking about this? First of all, according to this sort of thought process. Groups, first factor tells us groups, second factor tells us how many are in each group. So I wrote 3 groups of 5. How are we going to be thinking about this problem here? Part A. How should I be thinking about this? Similar to what we thought about here on this last problem. Leroya. Fantastic. I like the idea of thinking of this 3 groups of negative 5. Will you please model? And if you have extra time, model it in a different way. Here are 3 examples of ways that we can model 3 groups of 5. How is that going to be similar or different than modeling 3 groups of negative 5? With your groups, please form at least 1 model. If you have time, form 2. We're going to pause recording as students think through this. Ready, set, go. All right, here is the most common one that I saw up on the board. I saw 3 groupings, and in each one of those 3 groups, I saw 5 negative counters. Whether you drew square tiles or you just drew negative signs, you showed me 3 groups of negative 5. The next one that I would like to point out is a number line, which was hard to squish in that amount of space. Different than the number line that we saw here. Here, all we saw on the number line was from 0 and the positive side. But if we're going 3 groups of negative 5, I think the only thing that I really need to worry about is the negative side. So 0 is going to be over here because I only need to worry about these negative pieces. There's 1 group of negative 5. Here's a second group of negative 5, which means I'm going to be down here at negative 10 now. And a third group of negative 5, which means now I'm all the way down here at negative 15. Which makes sense because we also had 5, 10, 15 counters, all of them negative, meaning it's negative 15 there as well. There's other ways that we could have drawn it. We could have drawn an array. This one is going to be just a little bit more time consuming. There's my 5 in one group. Let me lock all this in place. 5 negatives in a second group, and 5 negatives in a third group, and you can see even that array still shows that we have 15 of those negative counters. Again, what I'm seeing is 3 groupings, and each group contains 5 negatives this time. So what is that going to look like on part B? How am I going to model -3 times 5? Again, thinking of the same sort of concept here, 3 groups of 5. What is that even going to be? I'm going to pause recording as students have a chance to discuss and attempt to model this. We're only going to go about 60 seconds of student attempt before we go over it together. So 60 seconds, trying it on your own, and then can come back to the recording. Ready, set, go. All right, what are your thoughts? What are some ways that we can do this? I heard 2 groups come up with a solution. Trace, Davin, and Grant, what did you guys come up with first? Yeah, because multiplication is commutative, meaning I can change the order. So I can, if I want to, change this to 5 groups of -3. That is still going to be mathematically, it's going to give us the same result. Could we more easily model 5 groups of -3 than -3 groups of 5? Yeah, we definitely could do that more easily. However, is it a true model of -3 times 5? No. And is it going to help us over here? No. So that's one workaround. But I want to actually model -3 times 5. I'm going to show what I saw on Oren's paper. Oren did something like this, where he's showing 3 groups of 5. +5, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now this is a good start, but then he also, on the outside of his groups, he said, hey, by the way, that's going to be negative. And oh yeah, this is also negative, and this is also negative, because they're negative groups. What does this look like the answer is going to be? It looks like the answer is going to be 15, because I actually can count 15 positive tiles, right? But that's the challenge with this type of model, is what we're saying is, oh yeah, PS, everything is negative. It's a negative group. Even though it's positive, it really truly is a negative group. So we need to take all of this and turn all of these to the negatives because these are negative groups. So the answer is -15, but how can we get a true model of this? Here's what you all are forgetting. Do you remember we talked about this? Negative as opposite. Remember, we can say -8, but that's not the only way to read this number. We can also read it as the opposite of 8. With that in mind, Oren's model suddenly makes a lot more sense, because this is no longer -3 groups of 5. This is the opposite of 3 groups of 5. The opposite. So that means I can first model 3 groups of 5, just as we did, but then when I'm turning everything to its opposite, that means all of these positives are turning to the opposite. I have my 3 groups, but I'm turning everything in those groups to its opposite. But that also means it still looks like there's positive counters as I'm trying to turn them to its opposite. I'm still only counting positive counters, and I have to try and remember that they are negatives. So this is where I think a number line model works the very, very best. Let's go back to this last problem here. How can we show 3 groups of 5? On a number line, jump 1, jump 2, jump 3. So we have our 3 jumps. Each one of those jumps is 5 long. Let's do the same thing here. But because I've done this problem before, here's my hint and my tip for success. The 0 needs to go in the middle this time. So as you're drawing your number line, make it nice and small, or maybe do a vertical number line because we've got enough space for a vertical number line. I am going to draw 3 groups of 5. So drawing my 3 groups of 5, here's 1 group of 5. 2 groups of 5, and 3 groups of 5, there's my 15. But we also need to show the opposite of those three groups of 15. How did I show the opposite on the vocabulary? I drew that arrow saying, okay, now we're going to go to the opposite side of the number line, and we're going to do the exact same thing here. Here is three groups of 5, but I need the opposite of three groups of 5, which means I'm going to be down all the way over here at negative 15. And I'm going to label this arrow. Always label the arrow. That way we remember what we're actually doing. This is the opposite of three groups of 5. And now with that in mind, I want you to discuss what are we going to do here. We already realized that that first idea of commutative and switching the order isn't really going to work because now both numbers are negative. How are we going to show these negative groups? The key is in the opposite. Work with your group, 60-second head start. Go ahead and try this on your own and then continue the recording. Ready, set, go. All right, and what are we going to call this? How can I think about negative 3 times negative 5 so I can really truly model it? Carter? Yes. So this negative sign, instead of reading it as negative 3 groups of negative 5, I'm going to read it as the opposite of. And the opposite of what exactly? Well, I already took care of the opposite of. The opposite of 3, because the first factor is 3 now, and it represents 3 groups of, well, what objects am I going to be drawing inside of those groups? Negative 5. Not 5, but negative 5. So 3 groups of negative 5. Again, this one's kind of hard to model. Similar to this one before, yes, I can draw 1, 2, 3, 4, 5 inside of a group and have 3 of those groups, but then just like before, I've got to turn all of them to their opposite. So what the opposite of all of these negatives is now going to be positives. And again, that's sort of hard to model. So let's go to the number line and let's see how we can make this a little bit more clear using the number line. If we're thinking of it as the opposite of 3 groups of negative 5, the first thing that I need to model is 3 groups of negative 5, which we already did that over here for part A. 3 groups of negative 5. Again, I'm going to put the 0 right there in the middle so I have enough space to really do what I need to do. Here is one group of negative 5. Here's a second group of negative 5, and here is a third group of negative 5. My 3 groups get me to negative 15, but that is just 3 groups of negative 15, or excuse me, 3 groups of negative 5, which is negative 15. Now I need to go to the opposite of that. So if I'm at negative 15, I need to go to the opposite side of that number line where I am going to see a positive 15. The opposite of negative 15 is a positive 15. So the opposite of 3 groups of negative 5 is equal to a positive 15. Starting tomorrow, we're going to notice some patterns as we go through this. We're going to see some rules. But we're not quite ready for those rules yet, and so we need to just make sure that we are modeling all of these with number lines. So how are integers, positive and negative numbers, related to the models for multiplication? What I would just summarize here is if we have a negative number of groups, we think of it as the opposite of the groups. Okay, and now let's put all of this to practice. We've got some number lines, we've got some problems. Let's put it all to practice. One of the most important things is taking the time to write down what this actually means. So write the meaning of each multiplication problem in terms of a number line model, and then do the multiplication on the number line provided. You're going to notice that 3, 4, 5, and 6, man, they all sure are really similar, aren't they? Kind of similar in the ways that our first problems were on the first page. So what does 2 times 3 mean? Just like this model over here, the first factor tells us how many groups, and the second factor tells us how many is in each group. So I'm going to write 2 times 3. What it really means is 2 groups of 3. So now I can model that. Here's my first group of 3 going from 0 to 3, and my second group of 3 going from 3 to 6. So again, there's that first group, there's the second group. So 2 groups of 3, we can see we landed right here on 6. How is that similar or different to what I'm going to be doing here on number 4? Talk with your groups real quick first. Just a quick 5-second conversation. What is this one going to mean? How is it similar or different from the last one? Okay, and now share your thoughts with me. Joshua? Yeah, 2 groups of -3. So how is it similar to and different from the last one? If it's 2 groups of -3. Go ahead. Yep. So the last one also is 2 groups, right? Yeah. How's it different though? How am I going to model that on the number line? Okay. Exactly. Positive, 2 groups of a +3 means I'm showing my groupings to the right. 2 groups of -3 means I'm going in the opposite direction, showing my groupings to the left on the negative side. So there's my first group. There's my second group. First group, second group. Where did I land? At -6. So 2 times -3 is -6. And now, numbers 5 and 6 with your groups. I want to give you guys a 60-second head start here. What does that mean? Understanding what it means is the key to success so that we can correctly model it with our number line. So 60-second head start with your groups, and then we're going to come back together and go over it. Ready, set, go. Pause the recording. All right, -2 times 3, what does that mean? How should I be thinking of this? I've already heard from you once before. I want to see a fresh new hand. There we go. Liv. Really close. So when you say the opposite of, you're already taking care of the negative. So you don't need to say the opposite of -2 because the opposite takes care of that part right there. So I'm going to kind of color code so that we can see that. We have the opposite. I circled that part purple, and I wrote the opposite in purple to kind of make that connection. And now what do I have? Well, we already know how to think of 2 times 3. We think of that as 2 groups of 3. We'll model that in just a second. How should I be thinking about number 6? How should I be thinking about -2 times a -3? I already saw that hand. I already called on that hand. I want a fresh new hand. Grant, go ahead. Yes, but if it's 2 times -3, what am I really thinking? What does 2 times -3 mean? So negative means the opposite. The opposite of what? Sorry, say that one more time, Grant. Very good. 2 groups of, what is inside of that group this time? Negatives. So 2 groups of -3. If I wanted to, I could even color code this part up here and say that's 2 groups of +3. Let's model that now. Number 5, the opposite of 2 groups of 3. I can't model the opposite until I've modeled 2 groups of 3. Good news. We've already modeled 2 groups of 3, right? We model that up there. So 2 groups of 3 is first group, second group. That gets me to 6. Now I need to go to the opposite. So the opposite of a +6 is a -6. And I always label this so I know what that random arrow is. We're really showing the opposite. And again, I cannot, on number 6, I cannot model the opposite of 2 groups of -3 until I have modeled 2 groups of -3. So here's my first group of -3, here's my second group of -3. So 2 groups of -3 is -6. But now I'm ready to model the opposite of -6, swing around over here to the positive side, and label it the opposite of -6 is a +6. So -2 times -3, all of that should have been down here, is equal to a +6. Did I fill in the answers on the other ones? The opposite of 2 groups of 3. 2 groups of 3 is 6, and the opposite of that is -6. And I caught it on the other ones. Okay, let's practice this some more. Next set of problems. Okay, this next set of problems, again, we've got very similar. 6 times -3, 6 times 3, -6 times -3, -6 times 3, and then randomly 2 times -5 and -5 times 2. This time, it's not saying you need to write down what it means. However, it's always worth taking the time to at least mentally check, what does this mean? 6 times -3 means 6 groups of -3. So I should model 6 groups. Each of those groups is -3. So there's -3, there's a second group, third group, fourth group, fifth group, and sixth group. So I made it all the way down here to -18. I knew what to model because even though I didn't write down what it means, I still thought about what it means. Go ahead and practice these with your groups. If you finished, you can work ahead to the homework, but finish these with your groups and we're going to go over it on the video in just a few. Okay, number 8, I see 6 times 3, and I'm thinking of that as 6 groups of 3. So this time, my groups are positive. It's going to be going in the positive direction. There's 3, 3 more, 3 more. So far I've modeled 3 groups, fourth group, fifth group, and sixth group. So 6 groups of 3 is a +18. And now number 9. Man, I see negative groups. I can't have negative groups. So I'm just going to leave myself a note that this means the opposite. The opposite of 6 groups of -3. So that means the first thing I need to do is model my 6 groups of -3. I already know how to model that because we did that in our previous problem, number 7. So 6 groups of -3, 1, 2, 3, 4, 5, and 6 groups of -3. But now I can do the opposite. I finished with that last part. The opposite of a -18 is a +18. So the opposite of 6 groups of -3 ended up being a +18. I'm going to do the same type of thing down here for number 10. Number 10, I have a -6 times 3. I can't have negative groups, so instead of thinking of this as negative groups, I think of it as the opposite of 6 groups of 3, and I can model those 6 groups of 3. Modeling 6 groups of 3, 3, 6, 9, 12, 15, and 18. There's my 6 groups of 3 at 18, but now I need to go to its opposite. The opposite of 18 is a -18. And to finish up these last two groups of -5. So here is my first group. Here is my second group. 2 groups of -5 is equal to -10. But down below I have -5 times 2. I'm thinking of this as the opposite of 5 groups of 2. So I'm going to show those 5 groups of 2 first. 1 group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2, and 5 groups of 2. So 5 groups of 2 is 10, but now I need to go to the opposite of 10, and that's how I get negative 10. This is the opposite. So the opposite of 10 is negative 10. Negative 5 times 2 is negative 10. And that is it for today's lesson. Your homework is the 2.2a homework section. Anything we didn't complete in class is homework, which is just that homework section. That's it for today. Thanks for watching. There we go. There's that homework section. You can see it's a lot of the same thing as that we did in class. This time we are writing what it means, at least for the first half, and then the last 3 problems we do not need to write down what it means. We have a really challenging one here, number 15. What is that going to mean? So if you think about what it means, even though it doesn't require you to write down what it means, you will be successful there. All right, that's really truly it. Thanks for watching. We'll see you next time.